happening. Okay, so once again, welcome you to the second week of the statistical journey. And our agenda tonight is learning R as an introductory programming language. So, but before we go there, I will just have some discussion about statistics in general, and what's the feeling about statistics. People think about statistics given the numbers we try to grade out of the population or samples. What is the belief of it? And then some notes on the assignment, first assignment, because probably and Plain has discussed much on that issue, but still I see on the forum you have some little bit of doubt on that. So I just try to put some notes along that line, and then we will see R as a learning R as a programming language. And based on I'll just my quick sampling with you guys, I'll decide like the pace of the R library will cover on the next of the classes, like the coverage of the R we should do in specific sessions. So let's see. That will be decided by the learning, the knowledge given by this this cohort of the students. So let's start. I think so. The agenda I have already explained. So first of all, I would like to, we are learning statistics, and I just came up these two articles which just got my attention, and I'm sharing that so that you become aware of that. So because statistics, what is the general like acceptance of statistical figures and statistical value we try to report through studies or even scientific journals. So this is very daunting factor, like people doesn't believe statistics as numbers in general. So I have put these two interesting links for you to check out. So this is saying that I can sound is not I guess everybody is okay with my with the microphone. Yes, I think that's good. So yeah, generally some people, if you log in from your phone, probably that may cause an issue. So best idea would be to log out and log in further. So what I was talking about, the acceptance of statistics. So just on your spare time, you can look into that two links, but that gives us a kind of a heads up on our study design, because that's why people doesn't have a trustworthiness on the statistical figures. Probably because in statistics we try to estimate the parameters. So you know the parameter is just representing the population measure. So whatever we try, there is a like a average income of the population. We try to estimate the parameter through a sampling, and that's why we call like the mean, the average of the sample we collect. So if the sample is biased, if sample is not random, if sample is not collected in preparation of the population being targeted, then our statistical measure will be definitely not speaking of the population, it's speaking for the population. So, and in many studies that is flawed, and I have these are the common mistakes or common misuse that comes out from the mistakes of the statistician. So be aware of that. So that's why when in the first exercise, first assignment, we are trying to learn how to do a good statistical like a statistical study, like basically how to create a study, how to make a study, and you consider all aspects of the study's limitedness, like because no study is free from limitations. So every study has a limitation, but it is up to you. You identify those limitations and you put those limitation into consideration. This is all about your foresightedness and taking onto the table. That increases the trustworthiness of the study. Okay. So just I put this link, and probably that will touch you, like I have a link, semantic link of the statistical samples or the random samples you do through the population. So be aware in mind that yeah, if you sample, if your the statistical sample is not representative of the population, then there is a big question about the acceptability of the study in general. So that's why I just shared, and you can read that. So in regards to the assignment notes, just a few questions I just need to further clarify. So can the experimental design in assignment 2A be used for your capstone project? Yes, of course you can use it. And that to my suggestions. Um, uh, so to my suggestion, this is basically this will make your life easier, because then you are riding on the same horse. So you know from the beginning how you collected data, how your population is formed, how are you taking a sample from your population, and it's not what kind of bias that population may have, and then what kind of sampling technique you use. So it will make your life easier, and then it will make a consistent story, and it will towards the end of the course your life will be becoming easier, because you will not be able to you are not writing uh, something wrong with you. Yeah, so we'll be writing, then you will be writing a good capstone. You will be emphasizing more on your compilation of the report. So I ideally encourage you guys, yes, I'll come on the dataset as well. So I encourage you to whatever you do in the first assignment, because first assignment is nothing about collecting data or generating data, anything like that. It's about a plan. So is it like, that's the second question, do I need to collect the data for assignment 2A? Not at all. It's just a plan. So you think well ahead of time, like what kind of data you want to collect, and what could be your ideal study area, and from the study area what kind of data could be produced or could be collected. If it's an experimental design, so what kind of experimental design you are planning. Although the name is saying like it's experimental design, so it's a kind of a biased name for the assignment, I would say. Basically it should say study design, because study design could be like a experimental design as well, and also survey or crossover survey. So as I mentioned in the first lecture, so experimental design, although the assignment says, but it's not like you have to do an experiment and from your observational study you have to get the data. It's not like you can do survey, you can do yeah, you can get a different data source, but bear in mind that if you get the data from Kaggle, you should know how the data is collected, how the study was done, how the initial population was created, and then what are the parameters like, and what is the consideration and assumptions on that study. So you have to know all those, and probably some of the Kaggle data doesn't have those meta information available. So as Glenn has mentioned in this, it's always a good idea to have your own experiment, so you can learn it how you because everything is under your control, and you can see it, you can control it, and you know everything ins and outs of your study. So that's why it's recommended, but not like just you have to. But yeah, if you do your own, then it is like giving an extra experience of making a study design, and then finally how from the design perspective, then you apply different methods to get data, which is the second phase of this. And then you have to know which data should be dependent variable and which are your independent variables, like user response variables, and which are the causes for the response variable. Is there any relationship? What kind of relationship can be assumed from that? That will be helping capstone report as well. So if you know a problem exists with something, then probably that could be your first call, like to think like, okay, there is a problem I can see. Let's think this problem to be solved, or identify the problem. And then you're not solving the problem in the first study and in the study design. First, you are trying to make how to address the problem, like how to get hold of this problem. That is your objective of assignment one, first assignment 2A. So I think Glenn has made everything clear, and he's making his all effort to make you guys clear. but I would say the sampling technique should be like a you should like explain, like even if the study has a limitation, so take all those limitations into consideration. Okay. So, basically, there is no right and wrong answer of the assignment 2, because there is no wrong or there is no absolute right. It's all about your perspective, how you see the thing, how you see an environment, how you see a study, and then how you plan to design your study from that objective, from the perspective, from the environment. This is how you have to tackle that. And from that, obviously, you have to come up with a research question that should be representative of the specific problem you are trying to hit throughout this study. So yeah, don't overthink. Think simple, but think simple, I would say. So let's move on. So before I move on, and because next slide is about to show you the hands-on experience, like hands-on demonstration and some explanation about R. So before I go there, I would like to make a poll, just give an example, like a practical example of sampling, or just maybe have a good discussion point. So just making a first yes/no question. The first, if you have to say yes or no based on the question. So the question I'm saying, just listen carefully. The question is, did you use R or no R? It's like, did you use R any of your previous experience for any programming, or do you know R? Yes or no? Okay, just press there, and I can see the responses are coming. There are still no responses from 9 people, so if you can respond, because still we got 39 sign in to this, and we got 188 students. So yes, I will post some questions before I proceed on for R. So now still there are 6 no responses, but well, we see there at the moment. There are 9 yes and 25 no. So there is a big number of no that people didn't use R before. They don't know R basically. So they are new to the R. Okay, this is one. Like I just write the no response 5, then yes is 9, no is 25. Okay, this is one study sample I have got. Okay, now I will ask some questions after that. Okay, so now I'll make another question, another poll, which is probably three choices. So 3 choices. Okay, this is the 3 choice. Choice number 1 is, the question is, do you know any programming language? Okay, first choice, if it's no, means 1, like you don't know any programming language at all. If you know, and then number 2 is at least 1 programming language you know, and number 3 is more than 1 programming language you know. So this is the basically asking about your programming experience. If you know any programming language, then 2 or 3 should go. And if you are not familiar with any, and even probably 10-15 years you didn't do anything, any programming language, probably you can select 1. So I see there are 3 no responses. Wow, that's the, so just see no responses 3, and then 1 is 15, and then 2 is 8, and then 3 is 11. So we see 17 people didn't do any programming language at all, and that's why I just posted into the forum. So this is kind of a very basic lecture tonight about programming language using R. And I see some of the people have experience using any programming language. At least 1 programming language is 19 people, 8 plus 11, so 19 people of 39 people, they know programming languages. So okay, now what I have, this is an example of a kind of a sampling. Okay, so now the question to you, is it a like a simple random sample, like because the population is like 188 students, and out of the population, I could say like everyone has a fair chance to attend this lecture. So there was no bias, nothing like imposed on any of them. So you can attend, And of those 188, I see 39 students attended, and I had a poll of asking 2 questions, and you responded. And from the responses, I've concluded that most of the people in this cohort, can I conclude like most of the people in this do not have any R programming language background. Okay, so I am making this a statement. Do you think this statement is a representative of the population? Just if we can say no. Yes. Yeah. Okay. Okay. So I think this is all about argument now. Okay. I would say I would justify. Okay. Yeah. I think people will agree. People will not will not agree with me, and that is the exact point of view of assessment 1. So you can create a study design, and it is up to you as a lawyer kind of perspective. You define your case. You define your explanation. So I would say if I am the say no, this is totally a biased study, because I don't accept this is a representative of the population, because there could be some reason. Assumption would be like the lecture is happening at the night on a weekday, and this course is offered to only to the professional. So I assume most of the people have job, so probably they are tired. They are not willing to probably log in to have another session, so they're exhausted. Would this be a study done on a different time, probably weekend or any other time? Then could be mass participation. So the sample 39 out of 180, probably like a 1/4 of this population, probably is not a good sample that represent the population. And moreover, there was a kind of a announcement, like if this is an introductory, probably that has this deter some of the people from the survey. So this is the explanation of why this is a biased sample, or this is a biased study. Or it could be like even this is like a convenient sample, because I made my time convenient only this time to have a lecture. So this is all based on my convenient. I am making this the sample or sample study. So it's like a convenient sample for me to make a study. So these are the assumptions I could make, and I could then go ahead to explain this. So likewise, as I said, every study design. Yes, repeated polls. Yeah, there are definite techniques. I'm not going to the different techniques you can overcome this problem. Definitely, there are many ways you can have like a stratified sample. You can take a different like a sternum to have different groups, different timing. Yes, of course. Yeah, so that you get mass participations to populate to get a good representation of the population in your study. So this is the point I would like to make. So you can make a study design which is obviously limited, okay? But you have to touch base all the limitations they may have. So you have to think and you reflect those thinking, and that's make your study design more acceptable, trustworthy, or even like a fruitful, good for marks. Okay, so that's the only point I would like to mention here. Now I will jump to the R. So I'm just going to share my screen. But before that, just a little bit of a story about R. Probably we should pay respect and tribute, like at least thanks to the creator of R. They're from the University of Auckland. The 2 guys, the professor Ross Ihaka and the Robert Gentleman. These are the 2 professors. They created R. So I'm sharing my whole screen. Then I will run my R Studio, so you can see my R Studio like desktop. So I'm a Mac user, so I'll show everything using Mac. So if you are Windows user, so probably the same instruction will go. But this live demonstration is using Mac. And yeah, I think Mac it doesn't like a big difference between Mac and a PC installing R Studio and working with R. So just be mindful on that. So I was talking the language. The name came from the 2 authors basically who created R, the programming language. So they created R, and from their name. Okay, so just looking at the chat. Okay, sounds you should open session in R. Yes. So we are opening an R session from just you don't need to like do with me. Just you can follow the video afterwards. So I'll just explain R as a programming language tonight, but in the subsequent sessions, we will discuss the theory that we'll do in relevant weeks, and then implement those theory into practice using different data set, either supported with your lecture notes, or I will have my own data set. I will get some data set from Kaggle or from other sources and use the data set to do some statistical analysis, either is a parametric test or non-parametric test, hypothesis testing. So we'll do that on the studio. So this is our environment. So I'll just give you some so I guess everyone is comfortable having RStudio installed on your like a work environment, either it's a Mac or a PC. So I assume this is already there, and this is the environment we have. Okay, so you can create a file, new file, which is could be R script, or in the R scenario, there is we can create a script called R Markdown, which is not which is not required for this course, but R Markdown is a kind of a script like HTML, where you can have a snippet of R code and snippet of like a text code, and that could be sewed together. That could be into like a like that could be put together and compiled together as a PDF file or as a HTML file, and that could be like shared across the for the assignment or for a report. Okay, so this is the thing. Or you can create a presentation through R, or you can even you can create a web application through R, but we are not going through that. We are just simply doing R scripting. So I have created all the necessary code that I am going to cover today, which is a simple R script, which I'm now going to open through that. So file, I'm just opening the file, and then I put it on the desktop, and it is in the I just sort out by the then week 2, and this is week 2 R. Okay, so this is my like a script I have done, which I'm going to go through to explain R as a programming language. And from the editor's perspective, you can go to the R editor preferences. If you want to change the background and appearance, you can do through the appearance. If you are not comfortable with the font size, I just increase this to like a more from 16 font to 18. And yeah, the different compare and contrast you can use as your editor so that it comforts your eye. And okay, so I just increase the font size. Now, now we are entering into the very basics of R. So in R, for any programming language, so I'll take I'll explain R from a programming perspective, programming language perspective. So any programming language says the basic building block is variable. Okay, so variable is just a what is a variable? Variable that can vary over time, and that means you can assign some data to some place, and then you can do some operation on that data, on that value you assign to that. So the container of the value is variable. So in R, in like any other programming language, there are certain types of variables. R has basic 5 types of variable. They are called the basic type variable, and there are complex type variables. Okay, so R has a very these are the 5 type variable. One is the integer, or you can say the full number, or like a non yeah, this is like an integer. Another is like a floating point or a decimal point. So this is a kind of a discrete and a continuous, if you say categorical, the data perspective. And there is a Boolean or logical, and this is kind of a complex number, which is a complex number, and the other type is a character. So these 5 types are variable. There are 5 types, and there is a NA kind of, which is like a not a number, that kind of there's not a specific variable, but that is also a type of variable or data, which is not a basic type, but R has a special data type called NA. So we are not just bear in mind that are not like a specific basic type, but there's a special type of like a data. So we have these 4 basic type, and how we declare a variable, how we make a variable into the memory. So we just give a name for the variable. The variable name should be like I have named it as var1, var2, var3, var4, and var5. And each of the variable type has a specific like let me have a look on the chat screen. Yes, I've opened our session for the late arrival. Or is the poll for? Okay. Yes, so the poll was about if you know a programming language, or if you know R as a programming language. Yes. Yes, the poll was about, yeah, as I said, Ricardo has like explained. Yeah, it was about to know the part so that I can switch my pace of delivering of R as a programming language. Okay, so let's head back to our R session. Okay, okay, so we're discussing about the 5 very basic variable, and probably you are okay with that. So, and if there are 2 ways. There are ways like you name a variable, and the naming of variable should be meaningful. Although var1 is not very meaningful, but in your programming language, whenever you do program and when you will be submitting your report, the variable name should have a meaningful name, so that reviewing your code, either at like another coder, or even you come back after 3 months, you should know like what does variable mean. Just instead of I, J, K, if you just put the y, what kind of index is that, what is the purpose of the variable, just do in that way. That will make your code more readable and maintainable for like development. So yeah, that variable has a certain naming convention. It cannot be integer. For example, a variable name cannot be like 1, okay, just a numerical, or it cannot have a special character into the name. So there are certain rules in creating naming a variable. So I have created in this case like 5 basic types variable. And in R, how you can run this, because you see this is our console. This is the environment giving us a kind of this is your code space. This is your like output space where you can see the terminal and the console. Terminal where you can run DOS commands, or even like a Unix command. Here you can run your yeah, you see the output coming, whatever your script is doing. So R is not a like object-oriented programming like other programming languages, for example C++ or even Python, or like C#. But R is a scripting, like a procedural kind of language. So here it runs every line by line, and so that you can have a quick prototyping and you can see the output instantly. Okay, so it's basically interpreted language. So it's not so you interpret line by line, and each line give you a specific output, and that you can debug and you can see right on time. So this is the window, and the right window, the top right, we can have, this is our environment variables that we get. So I just clear everything so that nothing is there. And then this is our like a explorer, kind of file explorer. And here there is an important thing to set up our working directory that I will come back and see if it's not set, what kind of problem we may have. So just leave it as this. So if we get a plot, that plot will appear here. And if we see, because R is having a rich set of packages, it's basically a collection of libraries. So this is why R is becoming very popular, because almost any statistical problems are solved through any good packages. So R is a very popular tool used in Google, LinkedIn, or Facebook. These are big companies. They use R for their analytical purposes. So each is having a good coverage of different packages for machine learning packages, you can say. And that's why you can see there are like I have a lot of packages you can I have installed for different works. So, and if the package is loaded, there will be a tick, a mark next to that, and you can tick and untick to load the packages easy. But there's other ways to load packages while you need that. So these are the package explorer, and this is your help. So if you want to get a help something, then you can search here, or you can type here like say in this R norm, for example, and then the help will come here, and then you can read this help file. Just have a quick look on the chat screen. R Markdown requires the need package. Yes, but Sylvia, we are not doing Markdown. R Markdown is not our purpose of this lecture. So R Markdown is a special thing which requires special packages. And even if you from Markdown, if you need to compile it to PDF, you will require a different package to convert that into PDF. So bear in mind that you are not required to submit anything in R Markdown. So you just simply we are simply learning R scripting. Okay. But if you want to do that for your own, yes, there is a good R Markdown cheat sheet, and there are like good tutorials on the online. You can do that. So I was familiarizing you on the interface of R Studio. So we are here, and you can see you can read help. So just now we just go our R as a scripting language. So we have already created the variables, and how you can run this, like this portion of the code. You can select this like this, holding your mouse and then selecting the line by line, and there is a run button. So if you run it, you can see the script has run. And once this script, this portion of the code is executed, you can see if there is an error, the error will be displayed here and in your console. But since it is executed, you can see your environment variable has populated. Initially, it was empty. So ideally, when you run, it should be empty like this. You can empty it. There is nothing. If you run it, you will see these are the environment variables which is populated, and you can see the values inside. Okay, these are the values already like inside. So but we rarely deal with like atomic variable in R. We always do with a complex type of variable. So there are few complex variables in R. And now I'm going to reveal one after another. One is vector. The most important thing is a vector. The vector ideally comes from like vector mathematics. Okay, so a vector is you can see is a sequence of data elements. And I have put a note here. So vector is a sequence of data elements of the same basic type. So that means vector cannot have mix and matches of different data types in one container. So if you think variable is a kind of a container that can contain data, so vector is a specific container which can contain multiple data in one container. And yes, stored in memory, get stored in memory. Yes, everything gets stored into memory. This data is in the memory, and this is the memory footprint you can see in the global environment. Okay, so vector is a container of multiple data types. So to clarify this concept, I have created a different like 5 vectors. So using those variables and see the output. So first of all, the vector 1, C is for concatenation. C is for concatenation, which is a combine. And this 1 to 1, this colon 20 is giving a series kind of notion. So I'm getting from 1 to 20 as a number sequence stored into vector 1. So if I run it, and you can see vector, and you can say integer, which is the type. So you can always inspect the type of your class by CLASS class, the function name, which is a built-in function in R class, and give a variable name. For example, if you say var3, will give you the type of the variable, logical. Okay, so in this case, vector is showing you as an integer type, is a collection of integer, all the collection of integer from 1 to 20. That's how it's been created. And let's run the second line, vector 2. So look at the notation. If I put a brackets in the begin and end, that means it has a meaning. So it will do this thing, it will do this operation, and this bracket will do also print at the same time. So I don't need to like say print command, like print then vector 2. Okay, so if I want to do a shortcut, I can do like a operation and the print of this outcome of this execution. So this is the meaning of this extra bracket at the first bracket at the beginning and end of the statement. So that means it will do the execution of this thing and also print the result of this. Okay, so like this is why vector 2. Now if you do vector 2, I've run it. So vector 2 is a numerical. Look, vector 1 was integer, sorry, variable 1 was integer, variable 2 is a numerical. So now it is converted to numerical type. So as I said, vector is a sequence of data elements of the same basic type. That means it cannot contain both integer and numeric as it is. So it has to be converted. That's why you can see 4 has been a 45.99 is converted to 49, which is a kind of a rounding so that it looks same like as one type. Now look at the third example. Vector 3 executed, it becomes like a true. For 46, the true is converted to 1 as a numerical. Okay, that means it is doing some kind of type conversion, a type casting, we say. So and I will see I will say what is the logic for that. Now if we do this, vector 4 is already there. So if we say vector 4 and run it, we'll see the vector 4 is becoming a complex. So CPLX is a complex type. You can check by class type. So everything is converted to a complex number. C4 plus 0i and 46 plus everything is converted to the complex. The simple numbers is converted to the complex number. Now if we say vector 5, it is converted to all character. So that means you can see there is a precedence of variables. What will be converted to what? So that means if there are mix and matches of different types of variable, and if you try to put them in a vector, vector does some automatic type conversion and make them alike. And there is a precedence, like integer is converted to numeric, and then Boolean is converted to numeric, and then complex has higher precedence than other numbers type. And then obviously the most highest precedence goes to the character type. So any number is, because you see the numbers are coming to character in this case, and vector 5. Okay, so likewise you can see you have the different types of things, and if you see everything is converted as a numeric, because 1 to 5, then 10.5, and then next, because the next is the highest precedence type, basic type, so it is all converted. So the idea of vector is clear now. Is a collection of same basic data types, but it has it has a certain precedence orders to convert and keep the variables to the highest type. So let's see. Okay, integers are whole. Yes, is the numerical like a floating point number. Yes, the numerical are like floating type number. Yes, numerical are floating type, which is a decimal type number. Okay, now we'll touch base with another complex type variable, which is a list. So you see the limitation in vector, because vector always does changes. What my real type, the basic types are changes to higher type, or it's just automatically converted to some kind of type casting behavior. So in order to have this overcome, there is a help from using other type of variable called list. So list can contain of different types. So unlike vector, list can contain multiple types. So you just simply, if I run it, you can see my list here. Where is my list? List of 5 elements. You can see these are the different types. So I just open double click the list, and you can see the numbers with there are 4, and these are the different logical, complex, character. Although 4 is converted to as double, so consider that as a double or numerical. Okay, so these are the different like a list. So list can preserve the items. Okay, just have a look on the chat. Is anything interesting? Okay, cannot see the run result. Excel, anyone is frozen or just mine? Screen is frozen. Is everyone has? Okay, so do you think I can, because I'm not doing any activities, so this is the screen I have. So if I remove it, then probably you can see this, because that's the problem when sometimes screen gets frozen. Okay, vector 5 was last one. Yes, vector 5 was the last one. Let me then reconnect and then see, stop sharing, and then I will start to reshare again. And did that happen before, like the screen sharing? If it is nothing much happening, enter a screen. Okay, so just to share again. So yeah, so I was with the list. So I just run the list, and you can see the list has 5 elements: factor variable 1, 2, 3, 4, 5. And don't worry, I will share my code after the session, so you can run yourself and do changes and see their output by yourself. Just quickly, you go through one by one. So then printing list is giving you the list items, which you can also inspect through the variable inspector here, double clicking, and you can see the output. Okay. And likewise, if you want to create your own like a from vector, like a vector, so a list can also contain a vector. So I'm creating a vector like vector 1, vector 2, vector 3 of different size and different types. So I created the 3 vectors and putting all the 3 vectors into a list. That is also possible. And if you see my list, and this will give you a list of vectors. So you can see the list of vectors appearing and the output. So first element is a vector, and you can see now list. So it's a vector of this, vector 2, vector 3. So vector of integer, vector of double, vector of characters. So this is the list. So list, I think the idea of list is clear, which can contain different types of data into one container. So let me look, any interesting. Okay, that's good to know sometime. Okay, now these are extra things to jog your mind and thinking, like there is a list function, and the list function can have a the list. You can when you use the concatenation, you can use a recursive true, which is basically flattening a list. So the list can be flattened, which means if you run it, then you'll see what does flattening mean. If it's a print, you see a list appears like a flattened list. Okay, so then you need to know what is unflattened. So if I run this and if I print this, you can see this is the unflattened list. It goes by the variables. So this is like a unflattened version of the list. So if you try to make a list using the C function, which is the concatenation function, and these are the lists you are trying to create, and if you don't do recursive, then the list will be non-recursive. It will be unflattened. But if you do recursive, then it will be a flattened, like it's in one item, like as a flat list. Okay. But other way, you can also do unlist. So if you do unlist, there's a function called unlist of, for example, it's L2, that will automatically flatten the list. So there are 2 ways you can make a list look like a list instead of like a sequence of variables. This is the function list and unlist. And if you create a list, the recursive is true, that will flatten automatically. Otherwise, you can unlist. So just a tip. Then the other useful complex data type is matrix. This is basically like a row and column formation of the data. So it is basically a 2-dimensional, rectangular layout kind of data structure. So I have put note for you so that you can easily know the definition of this specific data type. So it's basically if I have a data like this, just I'm loading this data, and then I'm converting this data to a matrix. So matrix is the type, like we have used list, we have used like a vector, like a C, okay, C for everything converted as a vector, list is a list, and then matrix. Okay, so these are the function, built-in function to convert this data to this complex data type. So I am passing this data, which is a raw data, which is a kind of a vector here in this case, okay, which is a vector. Now I'm converting this vector to the matrix, and this is converting like a 2x3 row, like a 2x3 like dimension, like a 2 row, 3 columns. So if I run this, you can see, and if I see M, you can see this is the M. So 2 row, 3 columns. Okay, you can double click on this, you can see that. Other way, you can see this command is automatically shown. You can type on the console view, capital V, view of the variable name, then this view will automatically appear. Okay, so And yeah, so, or you can double click on the name of the data and it will give you the view. So now it's like how you want to access the first row and third column. So this is the value you can get, because you can see 1 3 means 1 3, which is the 6th, right? First row, third column. So in R, the index starts with 1. But other programming languages like C, probably if you know, the index, even in Python, index starts 0. But R as an index start with 1. So that's why you have 1 1 1. In this column is also 1 1 1 2 3. Here 1 2. So the 1 1 means this first cell, 1 2 the second, 1 3 is this, likewise. Okay. So but here in this case, if you print like I'm just printing M, you can see we have a very ugly kind of column name. So if you want to make it literally more meaningful, you can also name your column and the row. Like this example, like a matrix of data, and then the number of row and column you mentioned, and then okay, this is another parameter I will explain. Like a so have you noticed like how our data, because our raw data was 2 3 4 5 6, and if you said our 2 3 4 5 6 7, the data is filled up into this matrix form as a like a top to bottom, like top, so 2 3, and then goes for, like a first is fill the column, and then it then row wise. Okay, so it go by column. So if you want to make it by row, like mean if you want 2 3 4 should go as a row, and then likewise the data will flow, then you can use the by row, which is the third parameter, like first parameter, second, third, which is the fourth parameter, which I have put true in this case. Or you're always welcome to see your help, mat matrix. So you can see like this, you can see matrix, and the matrices will help. And here you can read the data, the number of row, number of column, and then by row, which is by row by default is, you know, the function has a default parameter which is false in this case. But if you have to be specific, then in this case I am putting a specific true, so that it goes according to the by row. So if I run it now, you can see the output. If I print it, you can see the name AB is the row name. I have A and B as a row name. C, D, and E is the column name. And then if I print, that has been printed, and you can see 2, 3, 4 becomes as a row. Then 5, 6, 7, the second row. So the data is filled by row. So by using this parameter, the data is filled. Okay, and if you want to access, it is more meaningful to access by if you know these indexes, we call that row index and column index. And A is the row, and A and B is the index, and the CD is the column index. And using those index variable, the label, you can access a specific data. So for example, if you want to MAD, which is the number 3, so A is this and D is 3. So you can see this is the AMD kind of variable. So now we will go to array, which is a complex kind of data structure, which is basically extension of matrix. So matrix is always a two-dimensional. Okay, it cannot go more than two-dimensional. So if you want to overcome the limitation of your matrix, the solution is array. So array can go like it's a n-dimensional matrix, you can say. Okay, so in this first array, in the first case, your data is this, even same data. Truly speaking, we don't array much in our data analysis. Okay, we use basically mostly on metrics, and which is another data frame which is coming next. So but for your understanding, for your knowledge, know that there's a different data types which is multi-dimensional. It could be like a multi-dimensional matrix. Okay, so and this is where you can create it. So the C44 is your matrix dimension, 4x4 matrix, and then each of the matrix is getting by 2x2 dimensions. That means 2 times 2 is a 4. There will be 4 matrix of 4x4 elements. Okay, so this is the definition. This is how it is saying. Okay, so if I print it, like if I create it, it will be complex to visualize, but you can see, you can print. So you can see these are the 4 metrics. You can see because 2 by 2 there are the 4. So one on first matrix, second matrix, third matrix, and fourth matrix, which is the 2 by 2. So it's an array, is a like a n-dimensional matrix, and you can also give a name to the matrix columns and rows, and having that you can easily access by the data by row and column. And if you don't specify, then by default all will be selected. For example, just run it, and then I want to see that specific, like 2, in this case D2, D4. Okay, so we have D2, D4, all the data of that matrix, like whole matrix is, but if you want to get a specific data point of one matrix, you can go by all 4 indexes. Okay, so we have 4 indexes, and you can specify all these 4s to get a specific data. It's basically extension of our matrix, but don't take it to like to your thinking, like creating, because with this type of data is rarely used in modeling or any calculation. Okay, so next important thing is factor. So factor is very important in a sense, like we have a categorical data. So we have different types of data in probably in your study design. You will say you'll get some kind of category like a male, female, or like a kind of a agree, disagree kind of a scale. So that kind of categorical data has to be like encoded, okay, or has to be numerically represented in a way so that computation can happen. Okay, so to encode that categorical data into numerical category, we use basically factor. So we factorize the different categories. Even if you have a numbers, the example showing here is showing a number of different numbers, like a 6, 3, 6, but you want to encode that a specific 3 means something, 3 should be meaning something, and then 6 should be meaning something, like a kind of encoding. Okay, so to do that, so we have a vector in this case, and we have a function called factor that basically factorize this variable, and it give you this. So this means factor has levels. Like, so we got, so that means of this there are 6 types of 1, 2, 3, 4, 5, 6 types of, there are 6 different kinds of numbers, or 6 different instances. How many of that of different type? You can put a summary function, summary of for example, in this case, factorized variable. You can see these are the so these are the this. Okay, I'll explain the summary, but before I conclude describing factor, because I'll also explain factor with the categorical data in the next as well. But look, this is showing like each and individual different types, what different unique numbers. Each unique numbers is representing through a levels. So level 2, 3, 6, 7, 11, and 12. These are the unique things in this, and these individual numbers comes as a levels. So now in the summary, there are two like a factor 2, like a level 2, you can say. There are 1 instances. There are factor 3. There are 2 to 3s. There are 3 6s in this. There are 3 6. There are levels. So these are the levels in this case, and each level has how many representation of the numbers. So this whole vector is represented through the factors using levels, and also get the how many of the represented through that factors. You can see that through summary function. Okay, so we will do factor. We will do a lot of factor things in the explanation in the next thing. So you will definitely get more explanation and see more hands-on examples using factor in the next weeks as well. So factor is basically helping you to convert your categorical data to numerical representation. So now, very important data type is data frame. Okay, data frame is basically the best way to remember is if you're familiar with in a database table. So in a database table, what you have a definition of a specific fact record, like a record in a row. So a row, if you think of a database of a person, the first name, last name, even an employee, probably email, and then contact number, then date of birth, this kind of every fact. So, and if you have like hundreds of employees, and each row represent each people, and then you have that data. And if you look from the column perspective, each column is representing of a specific data type. For example, first name is a string type or a character type. The date of birth is a date type. And then you can see a different, like an email is a probably string type. So you can see from the column perspective, different data types. But if you row, is a mixture of data. So it's a factor. The data frame is a mixture of, you can see the list and the matrix. Okay, it's a two-dimensional space, but a two-dimensional list, you can say. Okay, so list can contain different types of data, and it's basically a table. Okay, so it's it's a kind of a database table. We can read a database table into a frame, and then it becomes a very a special type of data structure in R, which the column represents a variable. So we will see that. So for example, we have air quality, which is a built-in data type in R. So if we are loading this data frame, so just a df, so data.frame will automatically convert this data, which is a table, into like a computable in-memory data. So this is how we create our in-memory data representation of this data, which was loaded into disk, and we are reading it, and now it's now in memory. So df, if you look it, double click, you can see df is loaded, and these are the columns. Ozone, solar R, wind. This is like a probably this is air quality data. You can see the different data types. Yeah, and we have a NA, which is a missing value in R. So this is loaded. And if you see, there is a variable called wind, temp, month, and you can specifically access, and bear in mind that R is case sensitive. So many other programming language, a variable may not be case sensitive, but R is very, very case sensitive. So even a small uppercase, will completely different. So I saw on of the forum, like people are struggling not able to run the code because issues with the caps and like lower and upper caps. So be careful about the name of the variable you mentioned, and you are trying to access that variable. So in the case of temp, would it be a small t? Then it will be a different type of variable. It's a missing variable, so it doesn't have it. So if I print, then you are only printing the values stored into that column, temp column. So we have a temp column. So we are printing only, we are getting only the data of the temp column through this assignment, through this this df is a data set, and then $ temp. This is accessing the temp data points of this data frame. So this is the convention. So you can access the same way if you want to access the wind. So we will use df wind, okay, to access that. And this is just you can create your own data frame. So like you have a vectors. In this case, we have 3 vectors, and now we are creating a data frame using the 3 vectors. And these are data frame created, okay. And now we have same, like we have another data set called cars, and we can load that car, and we can also factor that, and we can summary as explained before. So I'll leave the code with you, and you can run it. So now a small important thing is like the data frame. You can do some kind of conditional things in the data frame to manipulate data. That's called data wrangling, or type of data subsetting, okay. So in this case, we are, so just load the data set, otherwise it will not run. So just load the data set. We load the car data set, and then from the car data set, which is df2, let's have a look. It has 2 observations, 50 observations, and 2 columns, speed and distance, speed and dist. And now we want to get only the speed greater than 20 into our df3, another data frame. So, and see how many data we get through that. So if we are creating another data frame using a condition, so look, this is taking like take only, and then comma is important, and then it is the rest of the things will be automatically converted, like automatically taken. Like consider all of the data, like all of the columns and the condition is only the columns speed should be having more than 20. So if you run that, you will get less samples from this. So df is still, we have two variables here. You said df2 is still two variables, df3 is two variables, but our observation size has decreased based on the condition. So if you see df3, so all are 23, but still we have this is a kind of subset of data we get from df2 as df3. Okay, so now I will quickly go on the time is running up, so we'll just do on the logical. So in R we have logical operators, which is like if you say this is bitwise, just I run it, I have a vector of some logical values into one vector 1 and vector 2, and if I do this one and it is basically going like a bitwise, or you can say the element wise. Okay, so element wise and. But if I say double and, which is basically doing as an aggregated and, okay, conditional and. So it is what it is doing. Like if we look false and true and false, and then it is giving you the result. But in the first case, true and false is what? False. That's why you get false. False and false is false. True and true is true. So false and true is false. So you get this one by element wise. But now if you have to evaluate the whole thing, because if there is only one false, everything becomes false because of and. That's why your result is false at the end. By having two and is making a compound and of your whole like a vector and. Likewise, we have OR. This is the pipes, vertical pipes. We have OR operator, and the single pipe we have this OR. So if you say element-wise OR, and this is our like a OR. So at least one is true. In this case, OR is if one is true, then everything is true. So in this case, our statement is true because we have at least one true. So that means everything is true. And this is the exclamation, which is basically negation. Making everything negative. So it is like when it is like element-wise. So if you want to have everything upside down, just not of that. So I'll go on the condition. So as a programming language, this is called flow control. So the basic element, because you need to have some, so you know the logical operators. So these are the logical things you can do, and you can also some other conditional operators like greater than, equals to, not equals to. That is very common as a common sense wise. So you can using these and that kind of like conditional operators, you can create logic. Okay, that's why we call this called a flow statements. So the easiest example is the if. And this is the only probably like maximum used flow statement in R using if. So the syntax for if is very simple. You start if and then the condition. If it is true, then you must have a begin, like the curly parenthesis, start and end, and have multiple statements between that. But pay attention to that. In other programming languages, you could probably start a new line with an else, but R doesn't like it. You have to use start your else just after finishing this. It should be in a one line else. So you can have multiple if, else, else, and finally else. There is a switch operator, but we don't use switch much. And so if you want to use any conditional statement, if is enough. Okay, so you can, yeah, this is simple. You can just review. So now the thing is that, which is the functional operators, like functions. So we can create what is a function? Function is basically a group of that you create for your convenience that you can repeatedly execute. And then what is the purpose of repeated execution if the code is doing the same thing? That's why it comes two things with the parameters. So function can receive parameters, and using these parameters, we can do our computation with the same computation with different values, different variables. So in this simple example, you can create a vector multiply function in this case. Okay, vector multiply function is doing nothing, just multiplying this, or even product because vector product is dot product, or just the normal vector like multiplication. So you can do two types of product, and finally you are returning the value as a list. So this is a simple example of your like a problem. In this case, your problem was to multiply two vectors, different type of products. So you do it, and you get the result, and you putting the result into a list and returning it. So just let me have a look in the chat. Yeah. Okay. Yes. Yeah. Okay, so let's go. So I just put another complex statement as a function. For example, you can call the function repeatedly, which is called a recursive function. Okay. In this case, a function, you create a factorial, for example, because you know factorial of a something is that value times factorial n minus 1. The factorial of n is equals to n times factorial of n minus 1. So that is the formula we know. And that means there should be a terminating condition. So if you have to write a function, you have to know when the function should terminate. So that's why I put a terminating condition here. If n equals to 0, then return. So function should return. Always a function should return something, either null or any value. That should return. Otherwise, it will be like a it will not get any response. You will not be able to get any value from that function. Although you don't need a value, but still you need to return something from the function. So that's the syntax of a function. So you need to specify. That's why these are the keywords highlighted. You name this name of your function, and then you assign this operator, like assign this name as a function, and this is the keyword, and then this is your whole block of function. So, and in this begin and end block, you can like write your reusable code that can be used, and that you can call multiple times by varying parameters. Okay. So in the case of factorial, the factorial is defined as a fact function, and then is receiving a parameter n, and you are specifying different terminating condition. If n equals to 0, then factorial, then it's you know the result is 1. If n is equals to 1, then factorial also 1. Otherwise, you keep on returning by this function. So you have a factorial function, and you are again calling the factorial within the function. So if you call the function within the same function, that is called recursion. And how the computer handles that is an interesting the concept. They call that stack. So until unless it gets into the terminating condition, it keep on stacking the call of the functions. Once the terminating condition happens, it keep on popping up this result, and then results are probably multiplied. In this case, is n, and it's a multiplication, and then finally you get a result at the end. So it just you run it, and you can see how it is working. So this is the function is loaded. So if your function is written correctly, you will not get any error. Okay, as you can see, now I'm just calling it, and you can see this has been executed, and yeah, and you can see the result is 120. But this another concept, you can looping. So if you want to run this function for like many times, there is a concept called looping, which is a for loop. But I think we don't need to discuss for loop, because in our statistical things we will not have a loop. We'll have a loop, but this is the way is you can say use a for statement, and then you can start with 1 and 20 times and go and call the function. You can run this, then it will run this function, and you get the output like this. So this is looping. Probably you don't need it. And I put another example of function, which is a recursion function, which is probably you know from the mathematics Fibonacci series. You can run yourself and see how Fibonacci series is calculated through recursion. I leave it for you to debug and run and see how the function is working. Okay, so the other data type is a string, and in a string we have multiple type of functions, different functions. For example, we define the strings as you saw before. We can define a string with like a series of characters. Could be it must be quoted. It could be either single quote or double quote. So if you start with quote single, then it has to be ended with single. Otherwise, it will not be a valid expression. So, and then paste is basically concatenation. So if you want to concatenate this with that, you have a function called paste. But in C we have concat, or yeah, and many other, even PHP or Python, we have concat functions. So yeah, you can see. Okay, so you can see that if you see the print statement, yeah, we can see it's concatenated paste. And if you say number of characters within a string, you have an nchar. If you want to make every string uppercase, we have two upper, and you have to make everything lower, we have two lower. And if you want to get a portion of the string, we call substring, sub-str, and a starting character from 1 and up to 10 characters I want to extract from the string param from the str. So it will be the first 10 characters of that string. Okay, so this is starting from 1 and up to 10. So this is a string. And now if we, how to load a data. So now I am trying to load a data, but you see it's giving me an error because I have to explain you here. I have to the file explorer, and there is an important thing. We have a working directory, okay? Because if you see now, my working directory is not set. It's trying to load data named 50 startups.csv file. So I'm trying to refer a file, but the file is not here in the directory. That's why it's complaining this is not there. So in your while you'll be working, you will get this kind of issue at the beginning. So to overcome that, you have to set your working directory where you are working, and at least make sure that file you are dealing with is there. So to do this, in this case, it is on the desktop, and it is on week 2, and this is the file I can see. Okay, 50 startups or CSV is there. So I go there and set this as a working directory, and this is the command. So either you can copy this and paste at the beginning of your code so that your working directory is set from the beginning, or you can do like this. Okay, or yeah, or you can do a project, and then project will automatically have the working directory set. So yeah, so the idea is you have to set your working directory so that you can yeah, your file is easily located. So now if I run it again, you'll see the data set is loaded, and the key function is read.csv. So this is a CSV file, and I am reading the read.csv file, and it is loaded into dataset, and I can see that a 50 dataset has been 50 observation has been loaded, and this is a data set related to like 50 startup company, like some startup companies, R&D expand, administration, there are different things, and profit. So imagine this is a kind of a data set you got from a study. So you surveyed some startup companies, and you collected this data as an end of your study, and they are located in the. So these are the different things you have collected. How much spend they did in R&D, how much they spend in administration, and how much they spend on the marketing, where they are located, and how much profit they earn. So now you want to make some interesting question like, is the profit related to a state? Is there any profit relationship? Is there any relationship with the profit and with the R&D spend or marketing? So that kind of question you will probably could be a research question to answer. So this is an example of an example data set, and that is probably coming out through a kind of a study. So this is the way you can load up your data, read.csv. And this is another example, because as you have seen, we have the data like New York, California, and Florida as our state, and we want to convert these to numerical levels. That's why we are using factor. So in the factor, we have a state. In the dataset, we have a state as a variable. You can see a state is a numerical, and we have this New York, California, Florida. These are the unique levels. And then we are converting these levels to a numerical levels, so that 1, 2, 3, and this could be encoded. So if I encode that, and if I run it and save it as a new data point, and if I load it, view file, you can see is now there is no New York, California is just 1, 2, 3. So now all data becomes numerical, and it's ready for any statistical like operation. So now I'll be talking about something about random samples and sampling using R. So I will start with this is R simple function called sample. So R has a inbuilt function called sample, which can create a sample. This is your sample data, and this is the size of the sample, and this is another parameter called replace. So if you run it, you can see straight away the output. So we have 3 data, and we are selecting 3 out of 3 and replace true. That means whatever has been selected, that should not be selected again. Okay, that means if 2 is selected once time, then there is no way 2 will be selected again, because it's not in the data set to select. That means 2 is taken off, only then selection between 5 and 3. The replace indicates that. But if you say replace true, that means whatever is selected, there's a chance of selecting it again. That's why if I run again, you can see 532 probably is not again. So if you say 5 is selected again, in the first case 3 was selected again. So there's a chance of getting that selections be selected again if you replace this true. And yeah, this is a kind of a random sample. If we create like some values from 10, this 1000 to 2000, and if we to select 10, yeah, select that. Even this dataset could come from a random distribution. So in R, we have different kind of distribution. We have beta distribution, we have binomial distribution, we have normal distribution, we have Poisson distribution, and each distribution has like a specific functions. Like you know, you can give a probability distribution function, which is p-norm. If it is a normal distribution, we can get a random normal distribution. If it is and there's a called R norm. So in this case, we are trying to get a norm, like a random 10,000 data point from a normal distribution, and the distribution characteristics is like the mean is 50 and the standard deviation is 10. So this is the population parameter we are passing to get a like a sample from this population, and the sample size is 10, and this is out, and we are fitting it into a data set, which is data frame. So DF now is having that data set. What is DF? Yes, you can see that this we have got here, and now some graph is a histogram. We can create a histogram. This is giving us a histogram, and the summary is giving us a 5-point summary with a mean, max, then first quartile, median, which is Q2, and the mean, and then third quartile and maximum. Okay. So yeah, so I have to go a bit longer. I think if this is okay with you guys, because otherwise I can cover it in the next. If it is getting too late for you guys, I think I should stop here. But definitely I will start with some graphical presentation of the data in the beginning of the next week. Then I will cover the rest of the like content through R as well as the lecture. So now, is it okay with you? What do you think? Let me check. Okay, so I don't want to hang you for long, because it's a weekday and I know you are coming from work. So I really appreciate your presence, and hopefully we'll learn things new in our journey. So I'll upload the slide and also the code, and yeah, keep well. Thank you, and I stop the recording.